From now on, we will be talking about the other type of fans or fan that inverter equipment has. Up to this point, we had analyzed very well how an AC fan works in an air conditioner, but in inverter we now have different fan models, such as the DC fan and also the latest model that is UVW. In reality, its operation is the same as a DC, but I name it UVW to be able to distinguish it. Finally, we have one more model, which we will later explain, that is a combination of two. So now we are going to move on to the DC blower. The big difference with this fan compared to a common one is that they are three-phase current fans. They work exactly the same as an inverter compressor. As you can see, they have a large electronic board inside. They are completely computerized. Their connections to the electronic board also imply having some communication signal between the electronic board and the fan. These fans can be found in both the indoor and outdoor units. The one we are looking at is a typical example of a fan in an indoor unit. As you can see, it has 5 connection cables. On the one hand, on one side we have a red cable. On the other hand, we have a black cable. On the other hand, we have a white, yellow, and blue one. Each one fulfills a different function, and we will explain it to understand its operation and also to be able to make the corresponding measurements, of course. One detail that you have to keep in mind and get your mind around is that these fans are three-phase. That is, if you look inside the fan, you will find 3 points that will say U, V, and W. This is where the fan coils are connected. Pay attention to this detail. Externally, we do not have access to the 3 coils. We can only access them once we open the fan, once we remove the rear protection, and then we can already access the U, V, and W terminals. From the cables that connect to the board, we do not have access to those coils. Who feeds those 3 coils? Well, those 3 coils are fed directly by the IPM that the fan has. The IPM is the one that, after transforming the direct current into 3-phase current, makes this fan work. As you already know, when we talk about inverter compressors, the operation is exactly the same. It is an IPM with 6 IGBTs or passkeys that are powered by 15 volts and that make the fan rotate at the speed it wants. Of course, it will always receive a notice from the board to know at what speed it has to rotate. Let's go to that. We look at this image. We will go through one by one what is the function of these cables. In the diagram, of course, we have it, but well, we are going to explain it so that it is much clearer. The black cable is always negative. It is the negative power of this fan. The red cable is the positive power of 310 volts, in case you have 220. If not, it will be 155 in case you have 110. The white cable, well, we don't have white color, we'll draw it in gray. In fact, we have it, but it wouldn't be seen. We'll put it gray to be able to identify it and understand it. It is a direct current voltage, also positive, but of 15 volts. It is the voltage that the electronic board of the fan and the IGBTs need to be able to activate. The yellow cable is also a pulse in direct current, but that goes from the board to the fan. It is a 2.5 volt pulse that the board sends to the fan to inform at what speed it has to rotate. And finally, the blue cable is also a pulse in direct current, but the other way around, from the fan to the board. But this pulse oscillates between 14 and 17 volts. So, to understand it again, fan power supply. With the red cable, all the necessary direct current voltage is sent to power the fan directly, 310 volt, 255 or 180, depending on its voltage. This comes directly from the filter capacitor on the board. Black is the negative, which is shared for all positives. White is a power supply that the electronic board gives to the fan of 15 volts that comes out after the switched power supply. With this 15-volt voltage, the fan board can be powered and also the IGBTs to be able to activate them and create the three-phase current for the fan to rotate. Yellow is communication from the board to the fan through an average of 2.5 volts. And blue, on the other hand, from the fan to the board, is informing a kind of Hall effect to inform at what speed it is rotating. This oscillates between 14 and 17 volts. Understanding all these parameters is how we will be doing the corresponding tests. Of course, as always, the first test we will do will be without voltage. The first test will be to measure the resistance between different points, and that is what we are going to teach now. Let's go to another image. Very well, here we have it. If we want to check the operation of this fan in resistance mode without energizing, obviously with the fan outside, what we will do is measure between black and red in the first instance. The resistance that should give us is approximately 20 megohms. Very high resistance. Another measurement we can do at that point when making the measurement without voltage is to measure in diode position. This is another measurement we can do. If we measure in diode position, the approximate value that it will give us will be a voltage drop of 1.2 volts to one side and to the other side. Oh well. Why does it give us this value? Well, remember that directly from these 2 points to the fan we are entering an IPM. And you remember how the IPM works. Let's see it again. You know that the IPM had, on the input side, that we talked about a positive and a negative. Look that we always find a diode and another diode, a diode and another diode, and a diode and another diode. So, if I inject electrons from here with the multimeter in diode position, and I exit from here, the electrons will be able to pass through these diodes with a voltage drop, but towards this side they will be able to pass. So, from one side injecting electrons from here will mark me approximately 1.2 volts of voltage drop, which is the sum of two diodes, because it has to go through one and then has to go through the other. But on the other side, look that in reverse it will mark us OL, because we have the two diodes in reverse. So, injecting electrons from the positive, they have to pass and a voltage drop has to occur. Injecting electrons from the negative, nothing has to happen. Let's see a video in which I am doing that measurement. Now we can see the fan, we can see it well. This model is from LG. And we can see its label on which it clearly tells us what we were seeing a moment ago. And we are going to do that measurement in diode position. We inject electrons through the red positive and we have a voltage drop of 1.185 volts. With the black multimeter I inject electrons, and I inject them through the red of the fan, which is the positive, but if I invert the cables, what happens? I have to have OL, and it is perfect. The IPM is in good condition, at least as measured from the outside. So, that is another measurement that I can do on these fans, in diode position and in resistance position, at least between red and black. Very well, now to be able to measure the following points, for example black and white, at that point, so that you have a reference, the resistance will be approximately of 40 kiloohms. We always take black as a reference, black to white. And now we are going to go from black to yellow. And at this point the resistance will also be high, 200 kiloohms. And finally, between black and blue, and the resistance here will also be much higher because it is an internal sensor, approximately 50 megohms. So, see that from black to red the resistance is high, from black to white also, from black to yellow also, and from black to blue also. In the case of finding values much lower than these that we are going to take as a reference, we could say that some part of the circuit is short-circuited or is in poor condition. These are measurements that we will make from outside the fan. Measurements without voltage are measurements to which you can access with the fan in hand. But of course, there are more measurements to be made, and the other measurements are already on the electronic board and even with the equipment completely energized. In fact, to avoid going around in circles, you have to detect the values, the voltages that indicate here. These are the voltages that you have to be able to measure when the fan is placed on the board in the corresponding socket. We can see a socket on the board of those fans. So, having understood how the fan works on the outside, we are going to mention the following. If we see that it is damaged or any of these numbers or values is wrong, any of these components could be the problem. We can have problems with the IPM. We can have problems with some of the internal low voltage resistors, some of the SMD capacitors. Any of these components could be the problem. My recommendation is not to repair these fans, because when we disassemble them, we usually give them a small blow to the bearings and they never work well. If you detect a failure from outside the fan, I recommend direct replacement. Of course, sometimes you may want to repair and there is no problem. In the folder of manuals and diagrams that we will send you, you will find a Word file that says links to YouTube videos that are videos that I myself saw in which some people make different repairs. For example, there is a video in which the IPM of this fan is replaced. Finally, it is left with a small noise from the fan precisely because of disassembling it and touching it. But well, it can be done. The spare parts are available and it will depend on you. For the cost of the complete fan and the risks, I recommend not to do it, but well, you can see it. Please leave a comment if you have any questions.